All right, hello and welcome back. It's your boy Hank Hackerson at Hank Hacks Hackers, your favorite system and network attacker. We are jumping into Linux privilege escalation today. This is a pretty intense room, and I want to say it's actually a free room as well, which means that anybody can get access to this room without even getting a paid subscription. So this is very, very sweet. So I hope you're in this room and you've started your machine, and we're about to jump into all the nitty gritty details of this. It's a command intensive room. It's not theory. We're going to be running a lot of commands and doing a lot of really fun things. This is a part of the PenTest Plus pathway that is inside TryHackMe, and we are right here. So we just did Active Directory basics and breaching Active Directory. I just launched those videos, and today we're going to do Linux privilege escalation, not to be confused with the intro to Linux that we did, as well as the basic Linux escalation video that we did. So this is going to be a much more intense one. And then, we got lateral movement and pivoting next, and then persisting AD and credential harvesting, which I have not completed. So that's going to be something that we're going to complete together. So if you like this channel, if you've liked anything that I've put out before, or if you want to make sure that you stay in tune with all the future videos that are going to come out, please make sure that you like and subscribe and turn on the notification bell, and even drop a couple of comments in there just to say hi or ask any questions or anything like that. It definitely helps with the YouTube algorithm so that we can get more reach and increase the size of the community and help more people, so on and so forth. So it would mean the world to me if you could like, subscribe, turn on the notification bell, and drop a comment in that comment section below. And without further ado, we are going to jump into this freaking room. Let's go. Okay, this room is command intensive, meaning that there's a lot of stuff that we're gonna have to launch, and for each one, or for every couple ones, there's like a different machine that you have to launch, as you can see kind of from these green little buttons right here. So I've already launched the first machine, privilege escalation. Just as an intro, if you don't know what it means, it's basically to be able to gain extra privileges. So you may gain access to a system using weak credentials that don't have a lot of access. So resources that are left out of the purview of regular users, right? So those are the types of things that we're trying to access. So if you've gotten access as a regular user, you want to gain administrator privileges or root privileges, or at least the privileges of somebody who doesn't have, or who has more access than you do. And so this is kind of what it looks like right here. It's like the basic user, and then it could be the local admin, it could be the system, and it could be the super admin, stuff like that. So you want to essentially escalate your privileges until you get the highest level of privilege possible. And then you get to do some really naughty things. So you could reset passwords, bypass access control to compromise data, edit software configurations, enable persistence, meaning stay on the system so that they can't kick you out, or you don't have to re-exploit the system. You can change the privileges of the existing or new users, and execute any admin command. And that's where the juice is. That's where all the power is. So we want to gain admin privileges. And so that's kind of the intro of the room and really what privilege escalation is. Now, the rest of these things that we're going to be doing are all practical stuff, command line stuff. So I'm going to open this up in another window so I can just basically read along and execute the commands in real time so that you can actually see what it all looks like. And then that way we'll also find all of the answers to the questions that are going to be asked of us. All right, the first task is going to be the enumeration task. And as you can see, there's a bunch of commands that we can run, and there's a lot of things that we can read. So instead of reading all this and then doing the commands, which is typically what I usually do, and it ends up making a much longer video. Look at all this. Look at how long this freaking thing is. So instead of doing all this and then going to answer these questions, what I'm going to do is I'm just going to jump into it. And then from the very beginning, we're just going to run commands and answer questions. So that way it'll make it just a lot more efficient, in my opinion. And at the same time, we'll actually kind of get to see a live example of everything. So the first command that we want to run is the hostname command. By the way, if you have Linux, I mean, even if you don't have it, I hope you're just running all of this along with me. But if you have Linux, run it. If you don't have it, use the lab at TryHackMe and then start typing away. So the first one is host name. And so our host name is Wade7363. And we're going to get the host name. It's very basic. The host name is the actual host, meaning the machine. It's not the user. So let's just understand that. Then there's uname A, which brings the distribution of the machine. So it's Linux under Wade, and it has a generic Ubuntu 3.13 yada yada yada, SMP. This is the date on it, UTC timeline, and very very basic. But it just gives you some good information about the system itself, obviously the host name, and then the version of it, so on and so forth. So then is going to be the next command that we want to find. It's called proc version, and it's not really a command, but it's where things lie. So there's information about the system resources and the processes, and we can find this on a lot of Linux flavors, as they call it over here, but a lot of Linux versions and different types of Linux, and it's basically kind of an essential type of thing. So if we run this, we should be able to see what system is installed, right? So proc version, and there you go. Now it's permission denied, so it should be very interesting. So maybe we could do cat proc version, and that's what that says. So I can't open it because it's a restricted file, but I can read it, and the cat command helps us read things. And this is, by the way, this was covered in the Linux basics. So if you haven't gone through Linux basics or anything like that, you kind of need to do that so you can have understandings of basic things like ls, which will list everything that is inside the directory that we're in, or cd, which will take us back. And now if we do ls again, well, I guess we're in the root folder, so we can't go back any further. So this is kind of what that does, right? So you need to understand most of these things. And if I do clear, I'm going to end up at the very, very top of the screen, and we'll just kind of stay at the top of the screen here. And so we couldn't get access to the file itself. We couldn't open up proc version, but we can read proc version, right? So cat reads it for you. And that is very useful as well. And it gives us the same information as uname A, right? So another one is etc issue. And this is another one of those that is denied. But if you do cat etc issue, it should be able to read it for you. And it gives you the Ubuntu version of the system. And so this is, it basically says systems can also be identified by looking at the etc issue file, which contains some information about the operating system, but can easily be customized or changed. So while on the subject, any file containing system information can be customized or changed. For a clear understanding, it's always good to look at all of these things. So you can look at uname, you can look at, and so I can probably do this one more time. There's that. And then if I do, I can't do up. So this is not something that's available in this Linux. But if we do cat proc version, it'll give us a certain response. And then if we do cat etc issue, it'll give us a certain response. And so in this version, in the cat proc version and the uname A, the responses are pretty similar. There's some extra stuff that's inside this proc version. For example, the build at panlong, and then there's the GCC version, which is the compiler 4.82, and then there's Ubuntu 4.82, and the rest of that stuff as we already saw. And then when we do cat etc issue, it gives us a different version of Ubuntu. So notice the difference of that, right? Then we have the ps command, which to see what are the running processes here. And so we could do ps, and it shows us that these are the two running processes. Time to live, you have sh, which is shell, and then ps, which is, I guess, processes itself, and it has its own PID, and you can kill that PID or refer back to it or use it for a different kind of script. So it's pretty useful. The time to live is the terminal type used by the I'm sorry, this is not time to live. I misread that. It's TTY, which is the terminal type. Excuse me. So it's the terminal type that was used, which is, I guess, PTS/6. Then we have the time, so the amount of CPU time that's been used by that process. And then we have CMD, the command or executable that is actually running. And so for this example, we have SH, which is typically, it stands for shell, which is what's running. And then PS, which is, I guess, the process indicator. So if we do PSA, it will bring all of the processes that are currently running. And this, my friends, is a very long list, as you can see. And one of the interesting things is that we could choose one and then view that specific one. So if we do, the one that they used in their example is PSAXFY, which I can't see it in the list because I don't think it's alphanumerical. But if we clear the screen and then do PSAXJF, my bad, AXJF. If we do that, it shows us all of the screens below. So the process tree, that's what that does, my bad. So PSAXJF gives us the process tree. And as you can see, there's now, it's a different version, it's a different view that, so it shows everything that goes inside Anacron, and then everything that goes inside LightDM, and then inside its subfolders. So it gives us all of those. And then there's something called Whoopsie. I wonder what that is, right? So that is the view to be able to get the tree version, which is PSAXJF. And then we have PSAUX, which is processes for all users. And this, I mean, it's also a very long list. And it displays the user that launched the process as well, which falls under U. It displays the processes that are not attached to the terminal, which falls under X. Let's see if I can get that for you before we kind of go crazy. So the user, the PID CPU memory, VST or VSZ, excuse me. And looking at the PSAUX command output, we can have a better understanding of the system and the potential vulnerabilities. So you have the user, the PID, the CPU usage, memory usage, version. I think that's what that is. VSZ might be version, or it might be vsize. I think that's the size. RSS, time, type of terminal, stat, start, time, and the command itself that's running. And there's a lot of stuff that is here. As you can see, their user for this is message, the user for this is syslog. Then we have Avahi and a lot of stuff. And then there's a lot of stuff. So it doesn't make sense to read through all this. But so now we understand the PS command, which is for processes. And so the next one is going to show environment variables. And this is called the env command. And so if we type this, these are all of the variables that exist in this current environment right now. So there's the mail environment that is at bear mail Karen. User is Karen. SSH client is on this IP at these port numbers, at this port specifically the SSH. Then home is home Karen. Old working directory would be just basically the / sign. SSH type is this, so on and so forth. Log name, so on and so forth. So we get all this information here. And then we have the next one, which is pretty useful. It is sudo L for list. And so this starts showing you the requirements, or not the requirements, excuse me, the list of things that can be run as sudo for Karen, which is our current user. So it requires that I type her password, which was given us, and it was password 1. But notice something interesting here. It says that user Karen can't run sudo on this host. So Karen is not a privileged user. She can't run anything on here, specifically even the command sudo, meaning basically run something with root privileges. So even something as simple as list something, it doesn't give you any of that stuff, right? So that's very, very interesting. And then we did ls already, which is just the basic ls command that shows you all the stuff that we have in our current directory. And so if I did cd boot, for example, and did ls, it'll give me a bunch of things inside of boot, and then I can go back by doing cd dot dot, which is change directory. So this is again part of the Linux basics. And then now we should be back in the home directory for Karen, right? So this is some of the basic stuff that happens with ls. And ls is probably one of the most used ones. So there's different versions of ls that we can run, which is lsla, that instead of giving it horizontal the way that you just saw, it gives us a vertical thing, but now it gives us a bunch of different information about each one of these other directories. So specifically the permissions on the directory. And when you look at that, it says this first half is for the person who created it. So the person who created it has those permissions. This second portion, not half, so this first third, I guess. This first third, and then the second third, let me zoom in a little bit more. The second third right here gives us the group, and then this is everybody. So everybody being able to execute is kind of what this looks like. And then there's lost and found that only the root can access, so on and so forth. So this is another version of ls, which gives you everything, including the user who created it, including the permissions of the user, as well as the permissions that are available to everyone outside of the user. So we're going to clear this up a little bit and kind of let's see if we can go further up. And so now we're going to look at LSL, which would be another version of this, but it doesn't include that last bit. So if I did this one more time, so LSLA, notice how there's these two dots at the top, and then there's probably some other items that show up when you do LSLA versus if you did LSA. So LSLA includes those two dots, meaning you can go back a directory if you wanted to, or a dot which refers to the current directory. And then LSL, L doesn't include those, and it probably is missing several other things that showed up under LA. And clear, just so you know, that's how I'm clearing the screen. I just type in clear and press enter, and it does that for us. So now let's move on to ID. So ID is also very important. So the UID for Karen is 1001. Then the GID, the group ID, is also 1001, and then the groups is also 1001. This is going to be useful when we try to understand the general overview of the privilege of whoever we have. The ID actually shows a different ID number for each level of user, and I think for root it might be 500. I'm not sure. We're going to find out in a little bit. But from what I remember, I think root access gives level 500 access. And the note here is that it's worth remembering that ID can also be used to obtain the same information for another user. So we could do ID Frank, I guess. There is no Frank. ID root. Root gets, there you go. So the root ID is 0, and the GID 0 group ID is 0 for root. So there is that. And what was it? Was password 1. So Wade 7363. So if we did ID Wade 7363, does anything come? There is no such user. So that's only the host number or the host name, and there is no user that is called Wade 7363. Now here is an interesting little file for us. So as usual, if we try to open this, it's not going to give us any access, but there is something called the etc password file, which is really, really interesting because it helps you see what type of users are on here. And it doesn't show you the password as the name implies, but it does show you the users on here. So of course there is root, daemon, bin, yada yada yada. And then if we go down, we probably are going to find some other users, and it's typically towards the bottom. So we already saw Avahi that was attached to some of the processes, and then Whoopsie is a user apparently, and then we have Matt, Karen, and SSHD. So Matt and Karen seem to be some interesting characters on here. So if we cleared and did ID Matt, Matt is part of group 1000. He's now a group of 1001, right? So Karen was in 1001. So that's interesting. We can see maybe he has different permissions. Maybe he's a little bit higher up the food chain than we are. We can also, if we wanted to kind of just only see one portion of the output from etc password, because when you do this, and I'll just show you one more time. So when we do cat etc password, it gives you a bunch of information all separated by colons, right? And so each one of these things represents something. Each piece between colons represents something. So if you wanted to just see the name of the users, then we could do cat etc password and then do a pipe and cut by this, by the colon, and then field 1. So we just want the first field. And now it gives us only the first field, which is just the usernames. So this is pretty useful, and you could do this with almost anything that outputs information with multiple fields per line, and it makes it easier to read. And the etc password file is also greppable, meaning that I could go into it and separate with a pipe and do grep home, for example, and it will give me every line that has the word home in it. So Matt is in there, Karen is in there, Saned or Saned is in there, USB MUX is there, syslog is there, right? So you can grep for anything inside of most files, if not all files, they're greppable, meaning they're searchable. And then we can go into something called the history command, which shows you, oh, really? What? No way. It's supposed to show you the history of people's commands inside the terminal, including myself, for example. But it says history is not found. So that's interesting. We can usually, if we have some kind of remote access to somebody's profile, if you run history, you can kind of see everything that they typed into their terminal, and that includes usernames and passwords sometimes. And we're not going to say all the time, but sometimes, rarely, it shows usernames and passwords in their history because they may have done it several times. You know what I mean? They may have actually had to access certain things. So if I do this one more time, right? So if I do sudo l and it asks me for the password and I type in the password, that was just put into the history. Now I can't see the history, which is kind of annoying, but that was put into the history of the system. So that's always very, very useful if you can actually get access to it. The next one is going to be ifconfig, and for Linux and Unix, it's ifconfig. For Windows, it's ipconfig. And what that shows you is all of the IP addresses and interfaces and MAC addresses and a lot of other things about your current machine. So ETH0 is typically the name of the interface that is running for most Linuxes. That's like the main interface that we're on right now. And this is the address for it. So this is the IP address that we have. And then we have a broadcast address. And then we are on this subnet, on this mask right here. And then there is the local machine, or the local configuration, which always has this as the IP address. And it's on the subnet 255.0.0.0. So this is very, very useful information to always get, and this is one of those things that you just, when you're trying to find out what you're on and what you have, that's kind of the easiest command to figure out some really basic and necessary information. The IPv6, so the IPv6 address is here, and we might even be able to find the MAC address. No, I don't think the MAC address is on here, but that's very useful. You have the IPv4 as well as the IPv6 address, and you can get the broadcast address. You can see the this is the MAC address actually right here, so my bad, that's the MAC address. It says hardware address. It doesn't, it sometimes says MAC, but a lot of times it probably says hardware address, and the subnet, and so on and so forth. So this is a really useful command. ifconfig helps you learn a lot about the current machine that you're on and the configuration of the machine. Then we can be looking at something like IP route. That, whoops, let me just clear and then do it above here. So IP route now shows us again the IP address, pointing to the interface and the main. So this is the subnet, right? This is the subnet that we're on, and the other version that we saw was 255.255.0.0. This is 10.10.0.0, and then ETH0, and then we have the actual address, right? And then that's kind of basically it, right? So, because this particular machine that we're on doesn't really have much information on it. Then there is netstat. Netstat is for looking at existing communications, and it can be used with a lot of different options to gather information about the current connections. And so let's clear this up one more time. We have netstat A, which shows us all of our, let's kind of zoom out a little bit, and it shows us all of our connections, and it says connected, it's a stream or it's a datagram, and it gives you the specific path that it's connected to, and a lot of great information about a lot of freaking things. So it's also one of those commands that pulls out a lot of stuff. It pulls out a lot of information. So it's either better, it's good to grep through it or try to cut specific pieces from it so that you're not so overwhelmed. At the very top of this, we see that SSH is in listen mode, localhost IP is in listen mode. There's been a connection made to SSH on some foreign address, it seems. There's another SSH that's on listen. IP6 localhost is on listen. On this specific port, it's closed and it's waiting, so on and so forth. So this is kind of a good overview, albeit like a pretty detailed view of the current, I keep going up. All right, I'm just going to clear it up. The current connections. And then we have netstat AT, which gives us the TCP connections, and then you could do netstat AU, which gives you the UDP connections. And you can just kind of read through that as well if you want to, but we're just trying to find out what is available. And then we have netstat L, which gives us list ports in listening mode. See, these are all of the things that are actually listening. And if you remember the ones that we did previously, there was a bunch of other options apart from listening, and then this list was actually much longer, but this is a much shorter list right here. And these are all the ones that are currently in listening mode. Then we can do netstat S, and this gives us the connections based on network usage statistics by the protocol. So this can also be combined with T or U, meaning TCP or UDP, to show you what the usage statistics are by that specific protocol. So you have IP, ICMP, TCP, and UDP. But if I wanted to just see UDP, I could do SU, for example. If I wanted to just see TCP, I could do ST, so on and so forth. And now we are moving on to netstat TP, which there we go. It lists connection with the service name and the PID information. So we have the protocol, we have the receiving and sending query, I think that's what it is, the local address, the foreign address, the state that it's in, and the PID or the program name But in this particular case, we don't have much, but that's what would be listed for you. And then we could do combine this with LTP, so what is listening, and it would show all of the ones that are listening, including their protocol, their query numbers, or I have to find out what that actually means. I don't want you to guess. If you can find that out for me and put it in the comments, that would be great. Then we have the local address, the foreign address, the state that it's in, and the PID in the program. And because most of the time, if it's empty, it means that it's actually used by another user. So it's kind of tough to see that information, right? If we try to run it with root privileges, we would be able to see it, but we don't have root privileges on this particular user. So that's kind of useless for us. And then the last one that I'm going to try to do here, or I don't know if this is the last one, but netstat I, it shows interface statistics it shows interface statistics. We can see that ETH0 and LO, because they were the only interfaces that we had, are the ones that are currently running, and it shows you what their usage actually is. And then you can combine these things with a lot of other stuff, right? So one of the common ones or more useful ones is netstat anno, and this is something that's been used a lot, and it can be broken down as A for displaying all the sockets, N for don't resolve any other names, do not resolve names, and O would be to display the timers. And so this is displaying all of the sockets, and it hasn't resolved any names, and it displays the timers. Let's clear this up, and let's move on to the find command. This is very, very useful. As the name implies, you can find a lot of things using this thing. So find, let's say, net flag. This is just a practice command that they gave us, and look at that. There's a lot of stuff, but most of them are permission denied because the particular user that we're on has nothing. And when you do find dot, that means you're searching in the current directory that you're in. If you do find home, it'll search inside home directory, and then those things are also denied. So you have home mat flag.txt. So let's see if we can read that. We can't. We don't have permission to that. Everything else is permission denied automatically. That's the one thing that showed up without the message permission denied, but then we can't read it anyway. Then you can do find / and then type D, and what this does is that it's going to show us everything that's named configuration or has config in the name, and the / at the very beginning means in the root folder, in the root directory, and recursive for everything else. Find something named, find the directory that has config in it, and of course all of these things we don't have permission on. And we can do the same thing with a file. So the first thing that we did was type D, which was a directory. If we do type F, we're gonna find a file, and then we do something like 0777 attached to the perm for permissions, and it should give you all the files that are readable. But we don't have access to any of these things. It should say they're readable, writable, and executable by all users. But unfortunately, it doesn't show me anything. I can't do any of this stuff. Like, all these things are permission denied, which is obnoxious. But I guess that's the point, because we're supposed to escalate privileges over here. Then you have find perm. So find inside the directory, inside the root directory, permissions A through X. And again, they're permission denied. And then we have find home, user Frank. Frank is not the name of a known user, but I guess find home user Karen, that would be one. And so there we go. And it's interesting that all of those things are also permission denied because I'm the user. So it's like, why is that permission denied? And then there's things like, find M time, which is modified time, and then you can attach a parameter to that. So find files that have been modified in the last 10 days, for example, would be like this. Of course, permission denied. Find A time, so accessed in the last 10 days, and that's also no permission. Find CMIN in the last 60 would give us access to anything that has been changed in the last hour, or excuse me, find CMIN 60, like that. There you go, permission denied. And then there's, files that have been accessed in the last hour, and then even files that are a certain size. So if we do size 50M, it would be files that are 50 megabytes, and we don't have access to those either. So find is very, very useful, and you can do find inside a particular directory or inside the home directory and everything inside of that. So it searches recursively, which means that if you give it the root directory and you say find within this, it'll search in all of the directories inside of that, meaning it'll search in all of these directories as well, right? So if we did lsla one more time, we can see all these different directories, and all these things have files in them. So we don't know which one it's in, but we want to search all of them. So you could do find and then just do the / and leave it as that, and it will only search inside the root as well as anything else that's inside it. You can also do find minus size or plus size to specify a file that's larger or smaller. What happened? This thing shrunk back down on me. You can do plus or minus so that it'll show you anything that is plus or minus 100 megabytes, for example. So greater than 100 megabytes. Or if you do find size minus 100 megabytes, it'll show you everything smaller than 100 megabytes, which is a very, very large thing. And I'm gonna stop this from running. Stop running. Okay, there you go. So let's move on to a very useful command that is called toDevNull, which basically sends all of those things that gave us permission denied errors, it won't show that to you anymore. So let's say find size greater than 100 megabytes, and the type is going to be a file, and to forward or greater than whatever dev null. And what that means is that all of those permission denied errors no longer show up, and it actually only shows us the things that we can access and that are greater than 100 megabytes. This is where it gets really, really useful. This is where stuff like this gets super useful. So that toDevNull kind of becomes our best friend when we're doing searches like this. So we can do find writable, which means all types that are either directories or files that are writable. And so in this case, it's going to be a directory. And then we're just going to do toDevNull. And there you go. These are all the directories that are writable that we can actually access, right? And another one. So find permissions that are 222, type D directory, and do toDevNull. And now it gives you all of the directories that you can write to as the current user, right? That's very important. This very, very freaking useful, this little toDevNull thing. When I found out about it, I was like, this is amazing, dude. So permission of write type D and toDevNull, nothing. We don't have anything in this particular user, and that's okay. So world writable folders is what we're trying to find, and it doesn't happen, but we had different types of commands that we could run that were able to actually show us that, because that the other one, find perm 222, oops, I gotta add that dash in the beginning, perm 222 type D and then to dev null. This also shows us world writable folders. So that is very, very useful. That to dev null is very, very useful. So what we want to do is we want to try to find things that are executable by the current user. So we're going to do find perm O X type D to dev null. And nothing in this case is executable by this freaking user. How crazy is that? Jesus. And then so there's a lot of other things that we could find. We could find things by their name, so Perl, and that is probably going to bring, oh, you know what? I forgot to use to dev null. So let's go find name, Perl, and then to dev null. Voila. And these are all the things that run on Perl that we can actually access. So that's useful. And we could do the same thing with Python, which is one of my favorite languages. It's probably actually my favorite language. Python to dev null. And all of these things are accessible by our current user. And lastly, we can find things that are GCC, so general compilers that are accessible by our current user. And that is going to look like this list. So very, very useful to be able to search through things, especially when you freaking use to dev null. It's one of my favorite things ever. So the last command that they're going to have us run here is going to be u equals s, and then we're going to do type f to dev null. And this specific one, it says permission user s, which is super user. That's essentially the, I don't think it actually stands for super user. It stands for set user ID. So what you can do is that you can run all of these folders with the permissions of the user who created them. And that's very important for what we're trying to accomplish with privilege escalation, because you need to find something that allows you to run it with the permissions of the user who created them, and ideally that user has higher privileges than you do, right? So that's really, really big deal. So the SUID thing we're going to actually go into in a couple of tasks from now, but that's something that's actually very, very useful that I'm very glad that I learned, and now you know, right? So find things that the user is S, or the user has SUID set, and it's a folder or a file, excuse me, and we do to dev null to get rid of all of the bad errors or the error messages, and now we have this list of things that we can actually use. So there are commands that are very useful in general, which is find, locate, grep, cut, sort, unique, things like this. These are all things that are covered in the Linux basics, so it's something that is actually very useful for you to know, and it's going to be something that we're going to end up using regularly as we go through the rest of this exercise and the rest of this module. So that was it for just a range of commands that they gave us. So now what they want us to do is they want us to actually find the questions to the answers. So the first one is, what is the host name of the target system? And you just type in host name and you get Wade 7363. What is the Linux kernel version? So if you remember, it's uname A, and it gives us this, and it's everything from this 3 all the way to generic. That's the Linux kernel version. What Linux is this? And if you kind of find that, it's Ubuntu, but we had to run a different command to try to find out what version of Ubuntu it was, and that was this thing. So cat proc version would give us the version of Ubuntu. Oh, it wasn't even that one, because it's actually, I think it was the other one. Cat etc issue is this thing, so it's that one. Ubuntu 14.04. That is the answer to that question. What version of the Python language is installed on the system? And I think we can do Python version. Python, Python 2.76. There you go. So just typing in Python will actually do it. And then if you notice, now there's these three forward arrows. That means you're actually inside the Python emulator, I think is what it's called. So now if I created, for example, variable equals hello world and did that, press enter, now I have this variable and I can do print variable and do that, and it prints for me hello world. So now we're inside the Python environment and we can run Python, which is very useful. And so we're now going to exit and go back into our regular shell. And so finally it says, what vulnerability seems to affect the kernel of the target system? And we need to go and find a CVE for that. And I'm just going to really allow you to go find that yourself. So you got to learn how to search through the CVE database to try to find the vulnerability that affects the target system that we're on right now. And I'll give you a little bit of a help here, is so that you can see what kernel version that you're running. It falls under this. So kernel version is in this thing right here. And it's very, very useful to try to find that information. It also is in this thing right here. So you actually have access to it in multiple situations where you can find the kernel version. And so once you find the kernel version, then you can go to the CVE database and you can just Google that. And then from there, you can just run that kernel version inside the search, and then it'll show you what the vulnerability is. And it's CVE numbers. So that's typically what it is. And yeah, that's pretty much it for this particular task, which was a pretty monster task. This thing right here, we just went through all of these commands together. So now we are going to move on to the next one, which is going to be automated enumeration tools. So all of the things that I just did manually, now you're going to learn how to do them automatically. All right, here we go. This is quick and very, very useful. So linpeas is a script that can be run to enumerate a system. Linenum is another one. LES, Linux Exploit Suggester, is another one. Smart Enumeration is another one. And Privilege Checker is another one. These are all previously written and established scripts or executables that you can use to enumerate a Linux system, either from the outside or when you're in the actual system. And it's very, very, very useful. I've used several of these before. I've used linpeas before, linenum before, and then there's another one called enum for Linux, I think, that can also be used. And it's all just very useful. Anything that you can do so that you don't have to manually run all of these commands to try to find it, that would, in my opinion, would be very, very smart for you to do. So we are done with enumeration, and now we're going to move into the actual privilege escalation tactics themselves and start running some fun commands here. Let's see, the next one, I think we have to, oh, it's still with Karen, so I don't know if we have to change the machine, but I'm just going to restart the machine and do it again just in case I have to for whatever reason. But that's it for enumeration and automated enumeration tools. We're going to move on to privilege escalation.